This video will cover section 1.7 on inequalities. Now, inequalities have multiple solutions, unlike linear equations, which only have one. So if you think back to when we were solving linear equations, when we got to the end, it just said x equals a value, and that was the only value we had. Now, if you'll look in your textbook on page 147, there's a chart that talks about all the different types of inequalities and how to write out the multiple solutions. We're going to look at that here, but if you ever need to refer back to it, it's on page 147 in your text. Alright, the good thing about linear inequalities is that they're solved very similarly to linear equations. Alright, with one exception. So when you're solving linear inequalities, if you divide or multiply by a negative, alright, you have to reverse the inequality. So if I divide or multiply by a negative, that's what you have to keep in mind. Alright, you have to reverse the inequality symbol. And we're going to see that here in a problem or two. Alright, now there are three ways to display your solutions to a linear, and that's supposed to be inequality, so if you want to mark that out. Alright, there are three ways to display the solutions to a linear inequality. One would be this way right here, where we just solve it. Alright, and we can see that x is any value that is less than 3. So when I pick a value to fill in for x, it can be anything that is less than 3. And that's an infinite number of possibilities that my solutions could be. And so we don't want to sit and write all of those solutions out. We'd be writing them forever. So there are a couple different ways we can write them out. Besides this way, we can use a number line. And so what I would do is draw a very basic number line. And on that number line, mark the number 3. And that 3 comes from right here. Alright, the 3 I mark on my number line comes from here, from where I've solved my inequality. And then I want to show on the number line all the values that are less than 3. So remember, on the number line, values that are less are always left. So if I want to get smaller values, I move to the left. Alright, so I'll shade everything to the left of 3, including the arrows. Alright, the arrows say it goes on forever, and so that would be in the negative infinity direction. And then if I shaded the right arrow, that would be the positive infinity direction. Alright, now I have to indicate whether or not I'm going to include 3 as part of the solution set. When you were probably first learning about inequalities, you used an open circle and a closed circle, and the open circle indicated that 3 was not part of the solution set. We're using that similar idea, except that we're going to be using another notation, and that notation uses parentheses and brackets. So that's what we're going to use on our number line. So I'm going to put a parenthesis there on 3 to indicate that I need everything up to the value 3, but not including 3 in my solution set. Alright, the next way we can indicate our solutions is interval notation. And that is used by writing the smallest possible value that our solution could be with a comma up to the largest value our solutions could be. And then anything in between this small value and large value would be a solution. Alright, so if you look at your number line, if you look whatever is the shaded furthest to the left, and that would be this arrow, so the furthest thing shaded to the left on my number line is my arrow, and that arrow is negative infinity. So I'm going to write negative infinity. Negative infinity and positive infinity always have a parenthesis next to them. Never any other symbol, so I'm going to put me a parenthesis there. Alright, and then if I follow my number line, the largest thing that is shaded, or the number shaded furthest to the right, is a 3, and there's a parenthesis on that 3. So there should be a parenthesis next to the 3 in the interval notation. Alright, let's look at the other inequalities. So, other than less than, we have greater than. Alright, and so let's put it on the number line. So this says x is greater than 3. That means any number that you fill in for x has to be bigger than 3. So I'm going to go to my number line and mark a 3. And on the number line, where the numbers get larger is to the right. So I'm going to shade everything to the right, including that arrow, to the right of 3. And now 3 is not part of the solution set, because if I put a 3 in x's place, that is not a true statement. But anything bigger than 3 would make it true. So I'm going to put a parenthesis on 3 to indicate don't include 3, but anything bigger than 3 will work. And that could be 3.00001. Anything bigger than 3 works, just not 3. Alright, and then I want to indicate that in interval notation. So when I look at my number line, the thing shaded furthest to the left this time is the 3. It has a parenthesis on it, so I put a parenthesis next to it. And if I follow along to the right, I end up at positive infinity. Always putting a parenthesis on infinity. Alright, now with the last two inequalities, the only difference between the first two and the last two is that now there's a line under the inequality symbol, and that line means equal to. And so what that means is I can have values less than 3 that would make this statement true, or now I can put a 3 in x's place and get a true statement. 3 does equal 3. And here I can put any value greater than 3, it would be a true statement, or I can also put 3 because 3 does equal 3. So it can be less than 3 or it can be 3. Here it can be greater than 3 or it can be 3 because they are equal. So the only difference in graphing these two is how we indicate the solution 3 on the number line. So in the first two we put a parenthesis because 3 was not part of the solution set. It would not make a true statement if I put 3 in x's place. Here, if I put 3 in x's place, it is true. So I want to indicate on the number line that 3 is part of the solution set. Alright, so I'm still going to shade all the values that are less than 3. But instead of putting a parenthesis on 3, this time I'm going to put a bracket on 3. And that says include 3 as part of the answer. So when I write my interval notation, the smallest value shaded is negative infinity up to 3, and this time I'm going to put a bracket on 3. Alright, for this one, x is greater than or equal to 3. I still want all the values that are bigger than 3, and that's to the right. And then I'm going to put a bracket to say include 3 as part of the solution set. Alright, so when we write our interval notation, it should match the way the number line looks. The first thing shaded on the number line is 3 with a bracket on it. Up to the last thing shaded is positive infinity, always with a parenthesis. Alright, so let's do a quick solve a couple of these. Alright, so to solve these work similar to linear equations. This would be like where the equal sign is at. Alright, so we're going to subtract 7. That'll give us negative 2x is less than negative 12. Alright, then note that here we divide by a negative 2. Alright, and we said anytime we divide by a negative, we reverse the inequality symbol. So it would become x is greater than 6. Alright, I want to put that on a number line. So I'm going to mark me as 6 on my number line. And I'm looking for all the values that are greater than 6. Alright, so that'll be all the values to the right. And then no equal to part, so that means the 6 gets a parenthesis. Then my interval notation should match. Parenthesis 6 to positive infinity, close parenthesis. Alright, let's look at the next one. Alright, this is going to treat that like it's an equal sign. Alright, we still want the variable on the left or numbers on the right. We want them on opposite sides, whichever side you choose. Some people like to keep their coefficient of their variable positive. Some people like to keep it on the left. It doesn't matter. Alright, so I'm going to subtract 2x. That'll leave 3 is greater than our equal. Nope. Sorry about that. It's about to skip a part. That will leave us 3 minus 6x is greater than or equal to 8. Alright, now I want to subtract 3. That'll give me negative 6x is greater than or equal to 5. Alright, notice how this is working just like those linear equations. Then I'm going to divide by negative 6. Alright, and now we're dividing by this negative here in the bottom. So we're going to reverse to less than or equal to negative 5 over 6. I didn't circle that answer up there, so let's circle this one. Alright, then we're going to put it on a number line. Still marking just like this. It doesn't have to be anything fancy. Alright, and so I want to show all the values that are less than. That's to the right. Alright, and this time it has the equal to part under there, so instead of a parenthesis, I'm going to put a bracket to say include negative 5, 6 in the solutions. Now, when I write my interval notation, I want it to match my graph. The thing shaded furthest to the left is negative infinity. And we're going to go up to negative 5, 6. It has a bracket on it. So we're going to close that bracket. Alright, so I'll show you real quick how to do compound inequalities. There are two types of compound inequalities, ands and ors. We're going to look at the and inequality just real quick. So notice that there are two inequality symbols. Alright, this just means that two inequalities were put together and we're looking for the solutions that those two inequalities have in common. What solutions do they have that are the same? And so we can put them together like this because really the inequalities look like this. Notice they share a common expression of 6x minus 8, so we could combine them together into one compound inequality instead of two separate inequalities. Now, if it makes you feel better to separate them out and solve them individually, that's perfectly fine. However, I think it's much easier to just solve them as they are combined together because you get the answer a lot easier. So you want to start in the middle and mark it just like any other equation would. And so I still want to isolate the variable. Alright, I'm going to do that by adding 8. Now, just with equations, whatever you do to one part, you have to do to the other. This one just happens to have two sides, well, really the middle and two sides, so 3 parts where I need to add 8. So if I add 8, I got to add 8 here and add 8 here. It's like there are two equal signs, so make sure you get on both sides. Alright, so now that gives us 9 is less than 6x, which is less than or equal to 12. Alright, then I'm going to divide by 6 because my goal is to get that variable by itself. That will now leave me an x. Alright, because I divided the middle by x, I have to divide both ends by, I said that wrong. If I divide the middle by 6, I have to divide both ends by 6. And then 9 over 6 simplifies to 3 halves, and 12 over 6 simplifies to 2. Now, really, there's no need to graph this, but if you were to graph it, you would take 3 halves, make sure it's on the left, and 2 is on the right, and then just shade between the two of them. And since that is a less than, that goes there, and greater than or equal to gets the bracket. And then when I write it in interval notation, it'll just be parenthesis 3 halves, comma 2, bracket.